Hey everyone, welcome back. This problem is also from the differential equations chapter of cracking the GRE math subject test. It's also pretty easy. It's a classic exponential growth problem, and you could write out the differential equation, something like dx dt, that's the rate of growth, equals some constant, I'll use c because they're using k in the problem, times x, and then you solve that, you get an exponential, and then you set the initial conditions, because it tells you that after 2 hours the population has tripled, and you arrive at the answer. But you don't really need to do all that, because just by reading the problem, let's erase this, you can kind of figure it out, because they tell you if you make like a table with the time and the population, let's say n for population, if it tells you that, let's say that at time 0, at the very beginning, the population is 1. Now, it doesn't really matter what their initial population is, so I'm just going to use 1 because it's easy. It tells you that after 2 hours, so at time t equals 2, the population is tripled. So that would mean that n would be 3. And then after 2 more hours elapse, so that would be at 4, the population will have increased by a factor of k. So every 2 hours, the population triples, so 3 times 3 would be 9. Now, it's not clear from the wording of the problem if they mean that it increased by a factor of k relative to the population at t equals 2 or relative to the initial population. But if they meant relative to the population at t equals 2, then the answer would be 3, and that's not one of the choices. So it must be that they mean increase by a factor of k relative to the initial population, or t equals 0. So we see that that means that the factor is 9. So the answer is C, 9.